Good day everyone. In today's video we are going to talk about instructional planning. So we have our two objectives here. First is articulate learning competencies and learning activities. The second one is articulate learning intent for a specific learning competency. So first we are going to talk about writing learning outcomes. In this video, we are to study three taxonomies. The first one here is the revised Bloom's taxonomy. So in Bloom's taxonomy, there are 6 levels of cognitive learning according to the revised version of Bloom's taxonomy. Each level is conceptually different. The 6 levels are remembering, understanding, applying, analyzing, evaluating, and creating. So using Bloom's revised taxonomy and assessment, these levels can be helpful in developing learning outcomes because certain verbs are particular, appropriate at each level, and not appropriate at other levels, though some verbs are useful at multiple levels. A student might list precedents or routines or participates to demonstrate that they remember something they learned. But generating a list does not demonstrate, for example, that a student is capable of evaluating the contribution of multiple precedents to American politics, or explaining protein folding, or distinguishing between active and passive participles. So first, we are to study the first level of Bloom's taxonomy, which is the remember. So remember, you need to retrieve, recall, or recognize relevant knowledge from long-term memory. For example, recall dates of important events in US history, or remember the components of a bacterial cell. Appropriate learning outcomes verbs for this level include cite, define, describe, identify, label, list, match, name, outline, quote, recall, report, reproduce, retrieve, show, state, tabulate, and tell. So in this part, the student will only retrieve or recall some knowledge from their long-term memory. The second level is the understand. So in understand, the student can demonstrate comprehension through one or more forms of explanation. So for example, classify a mental illness, compare ritual practices in two different religions. So appropriate learning outcome verbs for this level include abstract, arrange, articulate, associate, categorize, clarify, classify, compare, compute, conclude, contrast, defend, diagram, differentiate, discuss, distinguish, estimate, exemplify, explain, extend, extrapolate, generalize, give examples of, illustrate, infer, interpolate, interpret, match, outline, paraphrase, predict, rearrange, reorder, rephrase, represent, restate, summarize, transform, and translate. So in this level, the student should be able to demonstrate comprehension. So they will further explain because they already understand the subject. The next one is the apply. So the apply, the student can use information or a skill in a new situation. So example, use Newton's second law to solve a problem for which it is appropriate. Carry out a multivariate statistical analysis using a data set not previously encountered. So here the students should be able to apply what they have learned. So appropriate learning outcome verbs for this level include apply, calculate, carry out, classify, complete, compute, demonstrate, dramatize, employ, examine, execute, experiment, generalize, illustrate, implement, infer, interpret, manipulate, modify, operate, organize, outline, predict, solve, transfer, translate, and use. So the next level is the analyze. So In this level, the student should break material into its constituent parts and determine how the parts relate to one another and or to an overall structure or purpose. So for example, analyze the relationship between different flora and fauna in an ecological setting, or analyze the relationship between different characters in a play, analyze the relationship between different institutions in a society. So in this level, the student should apply um, more enhanced learning, because here they should be able to analyze the differences between two things. So appropriate learning outcome verbs for this level include analyze, arrange, break down, categorize, classify, compare, connect, contrast, deconstruct, detect, diagram, differentiate, discriminate, distinguish, divide, explain, identify, integrate, inventory, order, organize, relate, separate, and structure. The next one is evaluate. So evaluate, the student can make judgments based on criteria and standards. For example, detect inconsistencies or fallacies within a process or product, or determine whether a scientist's conclusions follow from observed data, judge which of two methods is the way to solve a given problem, or determine the quality of a product based on disciplinary criteria. So appropriate learning outcome verbs for this level include appraise, apprise, argue, assess, compare, conclude, consider, contrast, convince, criticize, critique, decide, determine, discriminate, evaluate, grade, judge, justify, measure, rank, rate, recommend, review, score, select, standardize, support, test, and validate. So in this level, the students can be able to evaluate a certain thing by following or by basing through a criteria or a standard. The next level is create. So in create, students should put elements together to form a new coherent or functional whole. We organize elements into a new pattern or structure. So design a new set for a theater production, write a thesis, develop an alternative hypothesis based on criteria, invent a product, compose a piece of music, write a play. So in this level, the students should form a new thing from the things that they have learned before. So appropriate learning outcome verbs for this level include arrange, assemble, build, collect, combine, compile, compose, constitute, construct, create, design, develop, devise, formulate, generate, hypothesize, integrate, invent, make, manage, modify, organize, perform, plan, prepare, produce, propose, rearrange, reconstruct, reorganize, revise, rewrite, specify, synthesize, and write. So the next taxonomy that we are going to learn is the Solow taxonomy and student learning. So Solow taxonomy is a systematic way that describes how learners' understanding build from easy to difficult while learning different tasks or subjects. The Solow taxonomy can be used to enhance the quality of learning within the classroom teaching and provide a systematic way of developing deep understanding. Student learning can be guided in ways that promote deep learning. So in this taxonomy, the learner should be able to build their understanding from the easiest way to the difficult one. So what is Solow taxonomy? So Solow taxonomy means structure of observed learning outcomes. It offers a structured outline for the learners to use to build their learning and thinking. It motivates students to ponder where they are presently in terms of their level of understanding and what they must do to progress. So Solow taxonomy as an alternative to Bloom's taxonomy. In 1982, Biggs and Collis devised the Solow taxonomy as an alternative of Bloom's taxonomy. From several decades, Bloom's taxonomy has been used to build learning and teaching strategies. Bloom's classifies learning from simply memorizing to more complex cognitive processes such as evaluating and analyzing. The Solow taxonomy offers a measure of understanding of thinking or cognitive learning outcomes that most of the teachers feel comfortable adapting. The hierarch model of solo taxonomy is comprehensive, provided with objective criteria and used for a variety of subjects and for a variety of assignments. Teachers like how Solo indicates student learning using diverse material in levels of increasing structural complexity, and that these levels show a similar patterns across back. So in Solo taxonomy, the students or the teacher should also be able to help the students to increase their learning. So Bloom's taxonomy versus Solo taxonomy. The Bloom's taxonomy implies that there is an essential relationship between the question asked and the responses, whereas both the question and answer can have a different level in Solo taxonomy. Bloom's taxonomy differentiates knowledge from the intellectual process or abilities that function on this knowledge, whereas the Solo taxonomy is at its core based upon the processes of understanding used by the learners when responding to the prompts. Hence, knowledge pervades across each level of the Solo taxonomy. Bloom argues that his taxonomy does not only relate complexity, but also relates a sequence of difficulty, whereas there is no such requirement of increasing difficulty in case of the Solo method. So Bloom's taxonomy does not accompany criteria for guessing the results of any activity, whereas Solo taxonomy is precisely useful for guessing the outcomes. Both taxonomies, along with a universal thinking framework, enable children to talk about their learning more effectively. So there are 5 hierarchical levels of understanding. So the Solo taxonomy has 5 hierarchical levels of understanding, and all the stages include the previous stage and add something to it. So the first one is the pre-structural level. This is an incompetent stage where learner does not know anything about the task or the subject. At this stage, the student simply gets unconnected information which has no sense or organization. The student remains unable to understand the information, hence he does not demonstrate understanding. So in this level, it clearly states here that in this stage, the learner does not know anything. So this is the preparation stage of the learner. The next one is the unistructural level. So in this stage, when learner knows just a single relevant aspect of a task or a subject, at this stage, the student only knows about the basic concept of the task or the subject. Therefore, a student can make easy and apparent connections, but he does not know the broader significance of the information. The student's response indicates concrete understanding of the task, but it pays attention to only one relevant aspect. So, unistructural, uni means one. So here the student only knows about the basic concept or the task or the subject. So they only focus on one thing, pays attention to only one relevant aspect. The next one is the multi-structural level. At this stage, the students knows numerous relevant independent aspects, although the learners understand the relationship between different aspects, but its relationship to the whole remains unclear. Concepts and ideas about a topic are not connected. The students can make several connections, but they do not understand the significance of the whole. The student's response is based upon some relevant aspects, but the responses are treated independently. So here the students already know numerous relevant idea, but they can make relationship or connections from those ideas, but they do not fully understand what is the significance of that whole idea. So the next one is the relational level. This is a stage where aspects of knowledge are combined to form a structure. At this stage, the student is able to understand the importance of different parts in relation to one whole. Concepts and ideas are connected. and they offer coherent knowledge of the whole. The student's response shows an understanding of the task by being able to combine all the parts. Students can demonstrate how each part contributes to the whole. So in this stage, the students can now be able to combine ideas. They can be able to connect ideas, and they can be able to know the relationship between those ideas that contributes to the whole. So the next one is the extended abstract level. So this is a stage where knowledge is generalized to build a new domain. After reaching this level, the student do not only make connections within the provided task, but they also create connections beyond it. Students can transfer and generalize the concepts and principles from one subject area into another domain. The student's response shows that they can conceptualize beyond the level of what has been taught. They are able to propose new concepts and ideas on basis of an understanding of the task or subject being taught. So in this level, through the connections that they already know, they can be able to go beyond what they know. They can be able to generalize concepts and principles from one subject area into another domain. So the last domain, taxonomy, that we are going to study is the Marzano and Kendall's new taxonomy. So Robert Manzano, respected educational researcher, has proposed what he calls a new taxonomy of educational objectives, developed to respond to the shortcoming of the widely used Bloom's taxonomy and the current environment of standards-based instruction. Marzano's model of thinking skills incorporates a wider range of factors that affect how learners think and provides a more research-based theory to help teachers improve their learners' thinking. So Marzano and Kendall's new taxonomy is made up of 3 systems in the knowledge domain, all of which are important for thinking and learning. The 3 systems are the self system, the metacognitive system, and the cognitive system. When faced with the option of starting a new task, the self system decides whether to continue the current behavior engaged in the new activity. The metacognitive system sets goals and keeps track of how well they are being achieved. The cognitive system processes all the necessary information, and the knowledge domain provides the content. So the 3 systems of knowledge. So the first one here is the self system. So it is all about the beliefs about the importance of knowledge, or the beliefs about efficacy, and the emotion associated with knowledge. So here the metacognitive system, the first one here is specifying learning goals, monitoring the execution of knowledge, monitoring clarity, monitoring accuracy. And here in the cognitive system, knowledge retrieval, recall, execution, comprehension, synthesis, representation, analysis, matching, classifying, error analyzing, generalizing, specifying, and knowledge utilization, decision making, problem solving, experimental inquiry, investigation. And the knowledge domain, information, mental procedures, and physical procedures. So as what you can see here, the 3 systems of knowledge, you can see that each level, from low level to high level. So first here, the knowledge domain. Traditionally, the focus of most instruction has been in the component of knowledge. Students were assumed to need a significant amount of knowledge before they could think seriously about an object. Unfortunately, in traditional classrooms, instruction rarely moved beyond the accumulation of knowledge, leaving students with a mental file cabinet full of facts, most of which were quickly forgotten after the final test. Knowledge is a critical factor in thinking. Without sufficient information about the subject being learned, the other systems have very little to work with and are unable to engineer the learning process successfully. A high-powered automobile with all the latest technological features still needs some kind of fuel to make its purpose. Knowledge is the fuel that powers the thinking process. So Marzano identifies 3 categories of knowledge, which is the information, mental procedure and physical procedure. Simply put, the what of knowledge and procedures and the how to. So information. Information consists of organizing ideas such as principles, generalization, and details such as vocabulary, terms, and facts. Principles and generalizations are important because they allow us to store more information with less effort by placing concepts into categories. For example, a person may never have heard an akpast, but once someone knows that the animal is a dog, he knows quite a bit about it. So um, information will help the student store more information or more knowledge about a certain thing. So next is the mental procedures. Mental procedures can range from complex process such as writing a term paper to simpler tasks such as tactics, algorithms, and single rules. Tactics, like reading a map, consist of a set of activities which do not need to be performed in any particular order. Algorithm, like computing long division, follow a strict order which does not vary by situation. Every single rules, such as those covering capitalization, are applied individually to specific instances. Physical procedures. This is the degree to which physical procedures figure into learning varies greatly by subject area. The physical requirements necessary for reading may consist of no more than left to right eye movement and the minimal coordination needed to turn a page. On the other hand, physical and vocational education require extensive and sophisticated physical process, such as playing tennis or building a piece of furniture. Contributing factors to effective physical processing include strength, balance, manual dexterity, and overall speed of movement. Many of the activities which students enjoy in their leisure time, such as sports or electronic game playing, require refined physical procedures. So we will go now to cognitive system. So the mental processes in the cognitive system take action from the knowledge domain. So these processes give people access to the information and procedures in their memory and help them manipulate and use this knowledge. Marzano breaks the cognitive system down into four components: knowledge retrieval, comprehension, analysis, and utilization. Each process is composed of all the previous processes. Comprehension, for example, requires knowledge retrieval, analysis requires comprehension, and so on. So knowledge retrieval, like the knowledge component of Bloom's taxonomy, knowledge retrieval involves recalling information from permanent memory. At this level of understanding, students are merely calling up facts, sequences, or processes exactly as they have been stored. Next is the comprehension. At a higher level, comprehension requires identifying what is important to remember and placing that information into appropriate categories. Therefore, the first skill of comprehension, synthesis, requires the identification of the most important components of the concepts and the deletion of any that are insignificant or extraneous. For example, a student learning about the Lewis and Clark expedition should bother to remember the road that the explorers took, but not how many weapons they carried with them. Of course, what is considered important about a concept depends on the context in which it is learned. So the information that is stored about a topic would vary by situation and student. Through representation, information is organized in categories that make it more efficient to find and use. Graphic organizers such as maps and charts encourage this cognitive process. Interactive thinking tools such as the visual ranking tool, which allows students to compare their evaluation with others. The seeing reason tool, which helps students to develop maps of systems. And the showing evidence tool, which supports the creation of good arguments, also serve the purpose of representing knowledge. So we will go now to analysis. Analysis, more complex than simple comprehension. The five cognitive processes in analysis are matching, classifying, error analysis, generalizing, and specifying. By engaging in these processes, learners can use what they are learning to create new insights and invent ways of using what they have learned into new situations. So, knowledge utilization. The final level of cognitive processes addresses the use of knowledge. Marzano calls these processes knowledge utilization or using knowledge. The processes of using knowledge are especially important components of thinking for project-based learning since they include processes used by people when they want to accomplish a specific task. So decision making, a cognitive process, involves the weighing of options to determine the most appropriate course of action. Next is the problem solving occurs when an obstacle is encountered on the way to achieving a goal. Sub skills for this process include identification of and analysis of the problem. Next is the experimental inquiry involves generating hypotheses about physical or psychological phenomena, creating experiments and analyzing the results. Third graders designing bean plant experiments and analyzing ideal conditions for growth are conducting experimental inquiry. Investigation is similar to experimental inquiry but involves past, present, or future events. Unlike experimental inquiry, which has specific rules for evidence based on statistical analysis, investigation requires logical arguments. In an experimental inquiry, learners observe and record direct data about phenomena. In an investigation, the information is less direct. It comes from the research and opinions of others through the writing, speaking, and other work. High school physics students who research current physics issues and use what they learn to persuade lawmakers to fund particular types of research are conducting investigation. So, metacognitive system. The metacognitive system is the mission control of the thinking process and regulates all the other systems. This system sets goals and makes decisions about which information is necessary and which cognitive processes best suit the goal. It then monitors the processes and makes changes as necessary. For example, a middle school student who is contributing to a virtual museum about different rocks first establishes the goal of what his web page will have on it and what it will look like. Then he chooses what strategies he will use to find out what he needs to know in order to create the page as he implements the strategies. He monitors how well they are working, changing or modifying how he is working in order to complete the task successfully. Next is the self system. As any teacher knows, providing students with instruction in cognitive strategies, even with metacognitive skill, is not always enough to ensure that they will learn. Teachers also are often pleasantly surprised to discover that a student has accomplished a task that they considered to be far too difficult. These situations occur because at the root of all learning is the self system. This system is comprised of the attitudes, beliefs, and feelings that determine an individual's motivation to complete a task. The factors that contribute to motivation are importance, efficacy, and emotion. So let's go to the first, which is the importance. When a student is confronted with a learning task, one of her first responses is to determine how important that task is to her. Is it something she wants to learn or believes she needs to learn? Will the learning help her accomplish a predetermined goal? Then the next one is the efficacy. Efficacy, as defined by a developer of social learning theory, Albert Bandura, refers to a people's beliefs about their ability to accomplish a task successfully. Students with a high degree of self-efficacy face challenging tasks head-on, with a belief that they have the resources to be successful. These students become deeply engaged in this task, persist at working on the task, and overcome the challenges. Bandura describes some ways in which students can develop feelings of self-efficacy. The most powerful way is through successful experiences. The experiences must be neither too difficult nor too easy. Repeated failure undermines self-efficacy, but success at over simple tasks fails to develop a sense of resilience necessary for persisting at difficult tasks. The next one is the emotion. Emotions, although students cannot control their emotions related to a learning experiences, these feelings have a huge impact on motivation. Effective learners use their metacognitive skills to help them deal with negative emotional responses and take advantage of positive responses. For example, a student with a negative emotional feeling about reading technical materials could decide to read his chemistry textbook when he is exceptionally alert rather than just before he goes to sleep at night. So now we are going to proceed to the next topic, which is articulating K to 12 competencies in mathematics learning with success indicators or enabling skills. So mathematics is one subject that pervades life at any age and in any circumstance. Thus, its value goes beyond the classroom and the school. Mathematics as a school subject must be learned comprehensively and with much depth. The twin goal of mathematics in the basic education levels, K to 10, are critical thinking and problem solving. Critical thinking, according to Scriven and Pohl, is the intellectually disciplined process of actively and skillfully conceptualizing, applying, analyzing, synthesizing, and or evaluating information gathered from or generated by observation, experience, reflection, reasoning, or communication as a guide to belief and action. On the other hand, according to Polya, mathematical problem solving is finding a way around a difficulty, around an obstacle, and finding a solution to a problem that is unknown. These two goals are to be achieved with an organized and rigorous curriculum content, a well-defined set of high-level skills and processes, desirable values and attitudes, and appropriate tools, taking into account the different contexts of learners. There are 5 content areas in the curriculum as adapted from the framework prepared by MathEd and SEI. Numbers and number sense, measurement, geometry, patterns and algebra, and probability and statistics. The specific skills and processes to be developed are knowing and understanding, estimating, computing and solving, visualizing and modeling, representing and communicating, conjecturing, reasoning, providing and decision making, applying and connecting. The following value and attitudes are to be honed as well: accuracy, creativity, objectivity, perseverance, and productivity. We recognize that the use of appropriate tools is necessary in teaching mathematics. These include manipulative objects, measuring devices, smartphones and tablets, PCs, and the internet. We define context as a local situation or set of conditions of Filipino learners that may influence their study and use of mathematics to develop critical thinking and problem-solving skills. Context refers to beliefs, environment, language, and culture that include traditions and practices as well as the learner's prior knowledge and experience. So here we're going to discuss the learning competency, cognitive, which the cognitive domain, affective domain, and psychomotor domain of the 5 content areas in the mathematics curriculum. So first here is the number and number sense. So example, learning competency. So visualizes and represents numbers from 0 to 100 using a variety of materials. So in forming a cognitive domain learning outcomes, students should be able to know numbers and represent it using different materials. In affective domain, students should be able to share the importance of numbers. And in psychomotor domain, students should be able to count from 0 to 100. The next is the geometry. Example of learning competency identifies names and describes the 4 basic shapes, which is a square, rectangle, triangle, and circle in 2-dimensional or flat plane and 3-dimensional or solid objects. So in cognitive domain, students should be able to know the 4 different basic shapes in 2D and 3D objects. In affective domain, students should be able to appreciate different shapes in their surroundings. And in psychomotor domain, students should be able to make a 2D and 3D basic shapes. So the next one is the patterns and algebra. Example of learning competency determines the missing terms in a given continuous pattern using one attribute. So in forming the cognitive domain, students should be able to know a continuous pattern using one attribute. And in affective domain, students should be able to demonstrate effectively continuous pattern using one variable. And in psychomotor domain, students should be able to determine a missing term in a continuous pattern. And the last one is, and the next one is statistics and probability. Example of learning competency: collects data on one variable through simple interview. So in cognitive domain, students should be able to know how to collect data in one variable through interview. In affective domain, students should be able to share the importance of collecting data through simple interview. And in psychomotor domain, students should be able to conduct a simple interview and collects data in one variable. The last one is the measurement. Example of learning competency: tells and writes time in minutes including AM and PM using analog and digital clocks. So in cognitive domain, students should be able to know how to write time in minutes using analog and digital clocks. In affective domain, students should be able to appreciate significance of writing time. And in psychomotor domain, students should be able to write time in minutes using analog and digital clocks. That would be our topic this day, and thank you for listening, and God bless us all.